Hi YouTube, Tim Unkert here. In this video we are going to be finding the sum of finite geometric series. We're going to use this formula, the sum of n terms equals the first term times 1 minus the common ratio r to the number of terms raised to the power of the number of terms, and that's all divided by 1 minus the common ratio r. Okay, so let's start with this first one. In this video we're not going to do any sigma notation, by the way, also. So we're just going to be doing geometric series where we have stuff like 2 plus 8 plus 32 and so on. So for this first one, we're going to actually write the explicit definition for the series so we can find the number of terms n. That's how we're going to start. So I'm going to say a sub n, the nth term, equals the first term. So the first term is 2 in this particular series, so 2. And then we've got to multiply that by the common ratio r. So the common ratio r, if we take one of these terms and divide by the previous term, so let's take 32 and we'll divide it by 8. The common ratio r is going to be 4. Okay, so we're going to multiply 2 times 4 to the n minus 1 power. Okay, a sub n is going to be the last term in the finite geometric series. So in this case, 32,768. So we'll put that there, 32,768. That equals 2 times 4 to the n minus 1 powers. Okay, so now we want to divide both sides by 2. And I'm going to switch tabs and go over to Desmos, and I'm going to do 32,768 divided by 2. That gives me 16,384. So I can rewrite this as 16,384 equals 4 to the n minus 1 power. Now I want to take this 16,384 and write it as 4 to some power of n, or to some power. Right, and then I can figure out what n is. So if I go back to Desmos, and I think I might have gotten rid of it. Let's go back to Desmos here. And so what we're going to do is we're going to do 4, and we'll raise it to the x power, and we'll say equals 16,384. Okay, and we see it's, just make sure that's right, yep. So that's going to be 4 to the 7th power. You notice that because the red here, which is, we have red, this red line goes through 7 on the x-axis, so x is 7. So I can say 4 to the 7th power equals 4 to the n minus 1 power. So now I can set 7 equal to n minus 1. And if I add 1 to both sides, I get that n is equal to 8. So now I know there are 8 terms in this geometric series. All right, so just remember that. So we're going to say the sum of the 8 terms is equal to the first term, 2, times 1 minus the common ratio, r, which is 4, to the 8th power, and we're going to divide all that by 1 minus 4. All right, so let's go back over here to Desmos. So we'll say 2 times 1 minus 4 to the 8th power. And then we'll make that all over 1 minus 4, and we get 43,690 as our sum. So 43,000. Let's just check. So I'm switching tabs here. So 43,690. And that's our solution to that first problem. Now practice makes perfect, so we should try some more. So let's go and try another one. And what I would suggest is, actually, if you want to try this on your own, pause the video, try it on your own, then see if your solution matches mine. Okay, so this next one we have another sum. We have 1 plus 3 plus 9 plus etc. all up to 59,049. So again, start with the explicit definition. Say a sub n equals the first term 1 times the common ratio. What is that? Well, if I take the second term, 3, and divide by 1, we can see that our common ratio here is 3. So 1 times 3 to the n minus 1 power. We're going to replace a sub n with 59,049. That equals 1 times 3 to the n minus 1 power. We'll divide both sides by 1. And we'll get 59,049 equals 3 to the n minus 1 power, because anything divided by 1 is itself. So now I want to get this as a power of 3. So if I go back over, switch over to Desmos, I can go up here to the gear here. I'm going to clear out this previous problem. And we're going to say 3 to the power of x equals 59,049. And is it 3? Yep, 3. And sometimes, okay, here we go. We got the red line here going right through 10. So it's 3 to the 10th power. Notice I had to zoom out. Now with Desmos, if you want to zoom back in, you can do the house. But now we don't see it. So I click this minus to zoom out. You see it goes through 10 there. All right, so we can say 3 to the 10th power equals 3 to the n minus 1 power. So now I'm going to say 10 is equal to n minus 1. I'm going to add 1 to both sides. And I'm going to get 11 is equal to n. Okay? All right, so we're going to look for the sum of these 11 terms. That's going to equal the first term times 1 minus the common ratio 3 to the 11th power, all divided by 1 minus 3. All right, so let's go over here. We'll do 1 times 1 minus 3 to the 11th power will be all divided by 1 minus 3, and we get 88,573. So our sum here is 88,573. All right, let's keep going. Let's do another problem. Okay, so what is the sum of the following finite geometric series? We've got 2 plus 10 plus 50 all the way up to 781,250. All right, so I'm going to say a sub n equals 2 times common ratio. So let's take the second term and divide it by the first, so 10 divided by 2. Or you could do 50 divided by 10. You're going to get the same result. It's going to be 5. So times 5 to the n minus 1 power. Okay, now we're going to solve for n. So we're going to say a sub n is 781,250. That equals 2 times 5 to the n minus 1 power. We're going to divide both sides by 2. 2's will cancel here. Let's go over to Desmos. Let's get rid of this previous stuff. So we got 781,250. 781,250 divided by 2. We get 390,625. So 390,625. 390,625. That equals 5 to the n minus 1 power. We want to figure out what power of 5 this is, so let's go back over to Desmos. I'm going to say 5 to the x power equals 390,625. And you'll see right now we got it in blue. That goes through 8. So it's the 8th power. 5 to the 8th power is what it is. So anyways, I'm going to write 5 to the 8th power equals 5 to the n minus 1 power. So 8 is going to equal n minus 1. I'm going to add 1 to both sides. And I'm going to get n is 9. So we have 9 terms we're looking for the sum of. So sum of 9 terms is going to equal the first term, 2, times 1 minus the common ratio, which is 5, to the 9th power, all over 1 minus 5. All right, let's go back to Desmos. So we do 2 times 1 minus 5 to the 9th power. We're going to divide that by 1 minus 5. And we're going to get 976,562. 976,562. So 976,562, that's going to be our sum for this geometric series. Okay, one more. What is the sum of the following finite geometric series? We have 2, then -6, then 18. We go up to 118,098. I can tell here that my common ratio is going to be negative because my second term is negative, but my first term is positive. So I'm going to say a sub n equals 2 times our common ratio. Figure that out. We'll divide -6 by 2 and get -3. And we'll do that to the n minus 1 power. All right, so we're going to say 118,098 equals -3 to the n minus 1 power. Now here's a trick coming up with Desmos. It's not going to be able to tell this easily like the other ones. I'll show you what we need to do. So we're going to clear everything. So we'll do in parentheses -3 to the x power equals, and let's go 118,098. And you notice we don't see anything. If I zoom out, we don't see anything. So we actually have to do here -3, and we'll start raising it. Let's go 6. Doesn't work. Let's go 7. Go 8. Okay, let's try 10. Getting closer. How about 11? 11 is a little bit more. What happened there? Well, we forgot to divide. Okay, so I messed up. We have to divide both sides by 2. I just took out the 2 there. So it's actually going to be 59,049. So that's why you need to check your work. I did that on purpose. Let's pretend. All right, so you notice here I didn't write the 2. I essentially had the 2 in front here and I had to divide. I was trying to skip steps. So that's going to equal -3 to the n minus 1 power. Now, if I did this and did 59,049, you'll see, even though I'm zoomed out, it's not really showing me it. So I still have to do this trick, okay, where I'm kind of, sort of guessing and checking at the value. But I can do that easily with Desmos. So, I can go down to 9, oh, it's too low. Let's go up to 11, oh, too high. Okay, we're going to do 10. All right, so 59,049. So I know that -3 to the 10th power is equal to -3 to the n minus 1 power. So 10 is going to equal n minus 1. I'm going to add 1 to both sides, and I'm going to get 11 equals n. Okay? So we're going to look for the sum of 11 terms, all right? And that's going to be the first term, so 2 times 1 minus the common ratio, -3 to the 11th power over 1 minus the common ratio, -3. Okay, so we'll do 2 times 1 minus -3 to the 11th power And we'll divide that by 1 minus negative 3. And we get 88,574. So our last sum is 88,574. And there we go. That's our solution to the last problem. Hopefully you found this video helpful. If you did, please like and subscribe. Thanks for watching.